morning, children. So, as we have started last day about the remainder theorem, and I have taken some example of numerical division and all. Now, once again, whatever I have done last day, that algebraic division, once again I want to repeat the same thing again. Just you see that I told you that three things you have to remember, most important three things. What are these three things? Sine of px and dx. Px is what? What is the meaning of px? Px is dividend. Then dx. What is the meaning of dx? Dx is divisor. Okay. So sine means, see, what is the sine of x cube? Because degree, highest power. Every day first we will start with the highest power. So here plus, here also plus. So that's why it's sine. Now here also plus, here also plus. So that's why there will be plus again. So if both are same sign, it will be positive. If both are opposite sign, then it will be negative. Irrespective of plus and minus. If this one plus, this one, see this one also plus, this one also plus plus. If this is minus, this is also minus. Suppose this one minus, this one also sign minus. Then it will be, also it will be plus. Then next one is the degree of the px and dx. So what is the degree of the polynomial px? Is x cube. And what is the degree of the dx? Is x is 1. So 3 minus 1 is 2. So that's why multiply. Then you have to see the coefficient of the highest power of the px and dx. So here highest power is 3, here highest power is 1, coefficient is 1, here also 1, so that's why 1. But here you see, here coefficient is 2, here it is 1. What is the LCM of 1 and 2? 2. That's why multiplied by 2. That's why multiplied by 2. Now last step you see, it is same. Here also degree 1, here also degree 1, positive, positive, coefficient 1, 1, so that's why 1. Because if you multiply any number by 1, this is the number is star. Okay. So these three things very, very important. Please remember these three things. Now let's say start with another division. Let's see. Same question, but divisor will be different. Divisor will be different. Okay. Same, but divisor will be different. So let's see. So next one is by x minus half. So divisor is x minus half. X cubed 3x square plus twice x plus 1. Now what is the power? So both are same sign, so positive, coefficient 1, 1. So here it will be x square. So x cubed minus half x square. Now you see minus, this is plus, so this one cancel. Then this will be 7 by 2x square plus 5x. Now you see, here coefficient is 7 by 2, here it is 1. So 1 and 7 by 2, LCM is 7 by 2. So plus 7 by 2. Degree 2, 1. So it will be x. So 7 by 2x square, then minus 7 by 4x. Now once again minus, so this one gone, plus. Now you see 3 4s up, so 3 plus 7 by 4. So ultimately what? 19 by 4. 3 4s are 12, 12 plus 7, 19. 12 plus 7, 19. So 19 by 4x plus 1. Now once again, here coefficient is 1, here 19 by 4, but degree is same. So it will be only 19 by 4. So 19 by 4x minus 19 by 8. Minus, so this one gone, plus. So 1 plus 19 by 8. So 19 by 8 means 8 plus 8 ones are 1, 8. 8 plus 19 will be 7, so 27 by 8. 27 by 8. Okay? So see, so last one remainder we got 0. This one remainder is 27 by 8. So last one divisor was a factor of the px or dividend, but here the divisor is not the factor of the given polynomial or px. Okay, last time dx and qx both were the factor because remainder was 0, but here remainder is not 0, so please be careful. Okay, now let's see next. Now next you see it is once again defined 1x plus pi, but dividend remains same, x cubed 3x squared plus 3x plus 1, and then so once again same, x squared x cubed plus pi x squared. Now here you have to see these two are like term but constant are different. So what it will be? 3 minus pi x square plus thrice x. Now you see once again, see this will be treated as one only, one coefficient only. Remember, there is not a two coefficient. So here it is 1, here 3 minus pi, so plus, and both are plus, so 3 minus pi x. So 3 minus pi x square plus pi x. Then minus gone. Then it will be, what is that? What I have written rightly? No, this one is supposed to be multiplied. So it will be 3 minus pi x. So what is that? Once again 3, then minus 3 pi, then plus pi square x plus 1 pi square. Okay, pi square. See, plus converted into minus, so minus into plus, minus 3 pi, minus into minus, plus pi square, so x. So here it will go once again, what is that? 3 minus 3 pi plus pi square. So 3 minus 3 pi plus pi square x plus pi bracket 3 minus 3 pi plus pi square. Then what is that? Minus, this is minus, so gone. Then 1 minus 3 pi plus 3 pi square minus pi cube. So 1 minus 3 pi plus 3 pi square minus pi cube. Done? So see, one thing you have seen, that if remainder is 0, then the divisor will be factor of the given polynomial. If remainder is not 0, then the divisor is not a factor. Neither the divisor nor the quotient. Okay. Now next they are asking now another method. So this is the way to find out the remainder. This is the way by the long division method. Instead of long division method, there is also another method that is also okay. We can find out the remainder. That is by that also we can find out the remainder. Let's see what is that. See, suppose px equal to x cube plus 3x squared plus 3x plus 1. Yes or not? And dx equal to, sometimes that dx is written gx also, so no problem. Dx and gx are same. Actually, generally written dx, d stands for divisor, that's the reason, okay? So equal to x plus 5. Now you know for what value it will be the 0 of the polynomial. So for what value of x it will be 0 of the polynomial. X plus 5 equal to 0 implies x equal to minus 5. If x equal to minus 5, then this will be 0 of the polynomial. Now, as x equal to minus 5, substitute here. Then you will get the remainder. See, p minus 5, then minus 5 cube plus 3 minus 5 whole square plus 3 minus 5 plus 1. Then you see minus 5 cube, 3 pi square minus 3 pi plus 1. Last time also we got the same. Last time we got this way. See, 1. And then we got 3 pi square. Then minus 3 pi minus 5 cube. So same thing. Here also you can finish, no problem. So here just I want to show you that last time when we have got the remainder by virtue of the division, that also same, this also same. Okay. Now let's see, by this method once again do one more question, that is question number 2 of exercise 2.3. Exercise 2.3. Remember exercise because I did not mention, so that you can find out which is the question I am doing. So that's the reason I did not write down the exercise number. Now I have written. Now question number 2. So find the remainder when it is divided by this. So px, question number 2. Px equal to how much? Px equal to x cube minus ax square. X cube minus ax square plus 6x minus a. Then once again you see dx equal to how much given? It is given x minus a. So x minus a equal to 0 implies x equal to a. Now substitute the value. P a cube minus a into a square plus 6a minus a. Then what is that? A cube minus a cube, 6a minus a. This one gone, so 5a. So what is the remainder? Remainder is 5a. This is the remainder. Okay. Now with this we can check if it will be 0, then it will be a factor. If it is not 0, then it will not be a factor. Okay. Now let's see next. That exercise 2.4, some more. Determine which of the following polynomial has x plus 1 a factor. Now already I told what is the reason? Divisor to be a factor of the dividend. What is the reason? Condition is that remainder should be 0. If remainder is not 0, then it is not a factor. If remainder is 0, then it will be a factor. Okay. So let's see. Now exercise 2.4. Okay. Now exercise 2.4. Let's see. See, it is given exercise 2.4. So it is given one Riemann one, suppose. Dx is given x plus 1. So can you tell me what is the value of x? What is the value of x? Value of x is minus 1. Then only it will be the 0 of the polynomial. Okay. Then let's see, px equal to x cube plus x squared plus x plus 1. Then p minus 1 cube plus minus 1 square plus minus 1 plus 1. Then what is that? Minus 1 plus 1 minus 1 plus 1. Gone? So 0. Therefore, x plus 1 is a factor of x cube, x square, x plus 1. Okay? Remember that. Okay? So, first of all, so last two questions I have shown how to take out the value of x. Now, already you come to know that what should be the value of x so that it will be 0 of the polynomial. So that's why no need to show actually. Okay, no need to show. So x equal to minus 1, now we substitute the minus 1, then minus 1 cube, minus 1 square, minus 1 plus 1. So minus 1 cube is minus 1, then minus power is even, so positive power is odd, then negative, minus 1. So minus 1 all cancel 0, so x plus 1 is a factor of the polynomial this one. Now let's see one more question, okay? 1 to 1, 4. 1 to 1, 4. See, so dx already what? X plus 1. So what is x? X equal to minus 1. Then px. Px is what is that? X cube minus x square minus 2 plus root 2x plus root 2. Okay? Then p minus 1. Minus 1 cube minus 1 square minus 2 plus root 2 minus 1 plus root 2. Then what is that? Minus 1. Then this is also minus 1. Then minus into minus plus. So 2 plus root 2 plus root 2. Then you see this one cancels. So ultimately 2 root 2, which is not equal to 0. Therefore, x plus 1 is not a factor of x cube minus x square minus 2 plus root 2 x plus root 2. So please don't forget to write down as a full statement once again, because that is the main one. Okay, so see, so you have got the value of x, so then this is the px, then substitute the value, minus already I told, power is odd, so negative, power even, so positive plus and into negative is negative, then minus into minus plus, so 2 plus root 2, then plus root 2, then you see minus 1, minus 1, minus 1, minus 1, how much it is? Minus 2 plus 2, gone, cancel, root 2 plus root 2, root 2, not equal to 0, therefore it is not a factor. Okay, now next, using the factor theorem, that means this is the one, using the factor theorem, determine whether dx is a factor of px in each of the following. So same, procedure is same, procedure is not different, procedure is remain same. Okay, then you do one thing, why I have written dx, I already told sometimes it may be dx also. So let's see. 2 Roman 1. So gx is given x plus 1. Then what is that? X equal to how much? Minus 1. Then you see p minus 1 equal to 2 minus 1 cube minus 1 square minus 2 minus 1 minus 1. So what is that? Minus 2 plus 1 plus 2 minus 1. So gone, so 0. Therefore, Therefore, gx is a factor of px. Now that means if gx is a factor of px, then remember px should be equal to 0. Gx is a factor of px, means px should be equal to 0. Px should be equal to 0. Remember that. If gx or dx, whatever it may be, if gx or dx is a factor of px, then px should be equal to 0. It is here x, polynomial of x. If y, then if it is t, then if it is z, no problem. Okay, there is no change. Okay. Then one more I will show, and then I will wind up, because with this property, by using this one, we'll solve question number 3, Roman 3. I'll do question number 3, Roman 3. Okay, so let's see. Question number 3, Roman 3. See, here it is given, find a value of k if x minus 1 is a factor of px. That means, as it is a factor, suppose we will do Roman 3. So, as it is, x minus 1 is a factor of px. That means what? That means px equal to 0 implies p1 for what value of x? It will be the 0 of the polynomial. Definitely 1, because 1 minus 1 equal to 0. Then you substitute the same value here. Then what is that? K into 1 square minus root 2 into 1 plus 1 equal to 0. Ultimately, k minus root 2 plus 1 equal to 0 implies k equal to root 2 minus 1. Okay, this is the value of the k. So then you please remember 0 of the polynomial and 0 polynomial. That is not the same, so please be careful for that. And whenever it will be a factor, that means px, that is remainder should be 0. If remainder is 0, then it will be a factor, otherwise not. So till then time, bye bye.